Hello everyone, and welcome to the second session. Okay, sorry, the kids. Part two of the COVID special session on RAVENNA and AES67. So getting deeper into the configuration, what is in the network, how the network works, and getting deeper also in the types of network you used. We will see the switches configuration on two different switches, so the Cisco and the Artel. And we will do a bunch of Wireshark captures to see actually what's happening on the network. And we will see a number of tools that are available. All of them are free to help you debug and actually manage your your AES67 and RAVENNA network. So let's go. And first with the PICs. So I had a little minute of talking about them yesterday on the standard session that is the beginner session that is available on YouTube still. If you want to watch that, you can have it on replay. So the performance implementation compliance specification is a series of tests that manufacturers do to their equipment to tell how much they conform to the standard. The problem or advantage of AES67 is that there are many different cases, and two equipments may be AES67 and not really able to, so on the extreme cases, on the edge cases, not able to exchange easily a stream. So most of the time this goes well, but the PICs are there to highlight this kind of problems, and especially the PIC summary that is available on what we saw yesterday, the PICs repository. So here you have two different PIC summaries of two different merging devices. The Linux has a driver, so this is a software driver, and because it's a software, it will, for instance, have a loose packet spacing, because software cannot ensure that you send a packet exactly every 1 millisecond, for instance. This is the Anubis, and the Anubis will, of course, have a strict packet spacing. When the Anubis tells you it's 1 millisecond per packet, it will be 1 millisecond every time between each packet. You also have everything that the device can do, and especially the ST2110-30 support, other PTP profiles, etc. And so the use of the PIC summary are mainly there to help you in the choosing and building of your AES67 network, to choose equipments that work together and that share the specification that you chose as a system designer, network designer, or just a technician for your own network. So for instance, you can choose that you will use streams of a lower packet time than 1 millisecond. Not every AES67 device is obliged to use packets of lower sizes than 1 millisecond. For instance, you can see that the Anubis knows them all if they are below 1 millisecond. The 4 millisecond is mainly there for the compatibilities with codec using the NASIP recommendation from the EBU. You also see that those sample rates. So at merging, because we are mainly promoting DSD and the DXD, we do all the sampling rates from 44.1 up to 394, and etc. The way you configure the QoS on the device, etc. So this should be as a way of choosing your AES67 device. This should be the first place you go to. That is this page here. So I always see the Yamaha PICs that we saw yesterday. So the PICs repository, which is getting bigger every day. And we can choose one more. So yesterday we looked at the Yamaha. So let's look at the ROS video. I will discover it in the same time as you. So you see that it does multicast, unicast, etc. Mainly the same as with all the merging devices. So this would be a device that is fully compatible with the merging device. And as a matter of fact, we did have the chance to test one on the lab. And it's working well in compatibility with everything that is merging based. So now the network. Once you have chosen the different devices that are composing your network, the thing is that how should I plug them together and what switches should I use? So this is a frequent question I get when I do presentation is, do you have one type of switch or the best switch that we should use as an AES67 switch? And there's no answer to such questions, as there is no answer to what converter should I use for recording, etc., or what mixing desk should I use. Every brand is there with many different devices, and they all have their specificities. Same is right with switches. But at some point, when your network gets bigger and more complex, you may need to look for specific features that you will only have in a subset of all the switches on the market. So at first, you start with multicast and quality of service, and all the switches that are recommended by the AES67 equipment manufacturers, they can do QoS and multicast. And let's define the lower tier. So the lowest tier of switches that are really good with using AES67 are the Cisco SG350 or those switches from other manufacturers that are in the same price range. And then when you get into a bigger network, you might need at some point a PTP switch, a switch that is PTP aware, and so on, meaning the capacity to do routing at the layer 3, the capacity to do multicast routing, etc. So all the switches, they are there for a specific purpose, and it's really about you, the system designer or the technician, to choose the switch that suits not only your need but also your capacity and the time you are willing to spend on the configuration. For instance, we have two different switches there, the Luminex and the RG. Even though they are roughly comparable in terms of raw performance, they are really different in terms of the way of configuring and the different things that you can achieve with the switch. So if you have a little time and you really want to achieve your goal fast, you will choose a switch that is easy to configure. And if you have more time and you really want to fine-tune your network, you might choose another switch. So interoperability. So AES67 is all about interoperability, and of course it's about being able to discuss between Dante and AES67, but if you want to get it a bit further, it's mainly about the need of integrating heterogeneous networks. So the fact that, well, I want a feature on a device that is only available in RAVENNA, and some other features that are only available in Axia, etc., using iWire. So this is also a use case of using AES67, is building a whole network around the technology AES67 as a way of doing your audio over IP. And one thing you are guaranteed with AES67 is that you achieve the interoperability on this format there. 1 millisecond, 24-bit per sample, and 48 kHz. From 1 to 8 channels, the sending device is required to send at least one of those channel numbers between 1 to 8, and the receiving device is required to be able to receive all those channel numbers. So this is the first step, but of course you will have limitation when you use AES67 equipment. If you remember, yesterday we tried AES67 with Dante, and with Dante we noticed that we have the number of streams that is limited, yet 32 streams is more than enough to do AES67 with Dante, but it's a limitation, and a limitation also that you can put only a channel in one stream and not 2 streams. So the full equipment capacity might not be available in AES67. It might also not be able to stream in other formats than 1 millisecond, 48 kilobits, 48 kilohertz, and 24 bits. And this is also true for Dante and other manufacturers. And this is a pain, and this was also a reason for creating the PICs, that, for instance, you have a merging driver that is AES67, and you wanted to do AES67 with a Dante device, and it doesn't work. And it doesn't mean that one or both are not AES67 compliant. It's just the problem that they are on different configuration or capabilities. And more importantly, they might not discover all AES67 streams, because the discovery is not in the AES67 standard. You can buy an equipment that has the label and rightfully has the AES67 label, and yet cannot discover the other RAVENNA streams, for instance, on your network. So this is why I showed you yesterday that you can copy and paste the SDP from one device to another, or have another way of manually configuring the device. So let's talk about the networks and talk about the AES67 from the point of view of a computer network, because it is first and foremost a computer network. So as any design rule for a network, you choose your components based on your constraints. So as I said before, the time you have to configure your network, the capacity you have, the knowledge you have in the technology, and the performance that you expect from a network. Some protocols become mandatory once you reach a certain sizes. So PTP is not really mandatory if you have a simple setup, 1, 2, 3 switches, except in very specific conditions. But once you get to really big networks, 5, 6, 7 switches, then at some point the PTP and the ability of the switch to do PTP configuration or PTP clock correction might be useful. Always remember that complexity grows with the network, so always try to keep the network as small as possible. And this can be viewed as the fact that instead of having 2 10-port switches, maybe 1 20-port switch if you can afford to have all the ports in the same place, of course, but only one switch is always better than 2 or 3 switches if you can accommodate with it. But it's also, the AES67 network is also a high performance network. So avoid everything that saves energy, that will try to lower the headroom between the actual working point of the network and the full capacity of the network. We want to have a lot of power available in a short amount of time, and also think that changing the topology, so changing the way the switches are plugged one to another, will have an impact. So this is not the things that you're not yet, I would say, the kind of things that you do when you're in production. Also overuse redundancy for security mainly, so as a safety belt, but it can be useful and it can save you at the end of the day. So learning from the experience of the IT world, as I said also yesterday, audio is a very small fraction of the IT business. So you learn from the IT and you try to use all those IT standards and all those IT best practices. You put them into your AES67 network one way or another. Okay, so let's get into the core of the network and the switch configuration. So multicast on a single switch is quite straightforward. On multiple switch is a bit more complicated, and when you discover it at first, it can be really messy, and then once you get it, it's a little bit simpler, but still. So the thing of multicast is that you have to have a central point for distributing the streams. So it's usually the spine switch or root switch, and all those other switches, their role is to not only do the snooping, that is distributing the streams going down to the other switches or devices going down, but also to send all the incoming multicast streams up to the spine switch. So this ensures that every multicast switch at every instant in the network goes to the root switch, and then the root switch will be the querier, will be the IGMP querier, asking the whole network what are the groups, what are the multicast addresses they are listening. In order to ensure that this is the correct port, that it is chosen by the switch to forward all the multicast addresses, you can choose the automatic mode. And good luck, because sometimes it doesn't work. Or if you design your network properly, you should use maybe the manual mode. Manual mode using the so-called router ports. And of course, because at each level of the infrastructure there are even more multicast streams going up, you will have accumulating bandwidth, and you may want to check that you're still using the 1 gig or even 10 gig bandwidth available on your interswitch connection. So let's do the experiment. And here I'm on the SG350 switch that is on my network. One of the switches that are connected to the root. So the root switch is 201 here, and I'm on the 129, so this would be the blue switch. So on the blue switch, I can go to the multicast configuration tab, and here is the multicast router port. So here I can directly configure that if I know that port 9 is connected to the spine leaf, to the spine switch on my network, or the root switch on my network, I can force the switch to send it all the multicast addresses. And then when a multicast address is registered and I want to know the detail of this address, it's always sent through port 9 also, and the other ports if needed. So we can see that for this stream especially, it's sent to port 8. So you can see that on some tools. So for instance, this is my tool that I wrote for that. So you can see that by reading the switch configuration, the switches configurations, you can check that everything is going right, well, and that the switch is actually distributing the multicast on the right ports. So you see that, for instance, for this switch, about 7 on the Ruby, nobody is listening to it, but it's coming up. It's coming up from the 2 Ruby ports up to the root switch every time. Even if nobody is listening to it, it's still going up to the root switch. And this is an advantage because when your number of streams is stable on your network, your bandwidth going up will be stable as well. So you avoid jitter problems, and you avoid cases that when you are trying to add a connection on the network, for instance, it doesn't work anymore, or etc. And we can see that it's the case for every device, every stream on the network. So this stream is coming from the Montone, and it is received by the RS148. This is not a stream. So this is received as well. This is not a stream. So here you have a stream from the RS131 that is also going up to the root switch. So these multicast router ports are very important in a multi-switch setup. And at merging, we provide configuration files for the single switch, and the configuration guidelines for the multi-switch setup for the Cisco switch. So of course, because it's a slave switch in terms of IGMP, here it will be, for the IGMP status will be activated, but the IGMP query will be disabled, so that the switch knows, and it can be done automatically or it can be done manually. So you see that here you can do the imports, so the multicast ports auto run, you can do automatically or not. You can use the immediate leave. So in IGMP v2, as I said yesterday, you can do immediate leave if you want. I don't recommend that because the devices sometimes then they miss a query, or when things happen in the network, especially in Ravenna and the MDNS, some devices are not behaving exactly perfectly, and you may leave a stream for a fraction of a second before trying to receive it. So if you check immediate leave, be really sure that you need it and that you tested it. And as a rule of thumb, just avoid immediate leave. Yeah, and then the query status can be also elected. So this can be really dangerous if you don't know what you're doing or don't want to know what you're doing. So Tibor, you ask, is there any config advice for Meraki Cisco Cloud Managed Network? No. No advice because I have no experience with it, but if you want to share or discuss about it later, I will be happy to take a look and to give you more information once I learn what it's actually. But it's a very fine question. I'm sorry, I don't have any answer for you. Yeah, so try to be as manual as possible, and even more when you don't know what you're doing, than when you know what you're doing. So as a matter of fact, if you are a merging customer, we are happy to help you and to give you advices, and even on the merging website, I had it, but it's gone. On the merging website, we are, it's there. On the merging website, we have, for instance, single VLAN configurations for or multiple VLANs configuration for those 350 switches, and you can also have a little more. Okay. So that's for the IGMP. Of course, when I go to the RTL Quora, I get the same type of, so when I go to configuration, to PMC, so IP multicast configuration, IGMP, which is the IP version 4, and I get the router port there. So here I am able to configure the router port, and there I have two router ports. Why? Because actually my port 8 is scanning port and diagnostic port that we will use for the multicast, for the network capture later. Okay. So then after IGMP, the real fun, PTP. So yesterday I was really fast on describing PTP, and let's take a bit more time on it. So PTP is using the two things to calibrate a slave clock. So the first thing is a regular tick that is sent and it depends. It can be every millisecond, half of millisecond, quarter of milliseconds. That has the exact time. So it's 1 p.m., it's 1 p.m. 1 minute, it's 1 p.m. 2 minutes, it's 1 p.m. 3 minutes. And this allows the slave to configure the speed at which the clock will go over time. So it should be enough, and it is enough actually in most of the audio use cases, but in PTP and in AES67 we want more than just the frequency and the exact frequency. We also want the exact phase. That is, we want that the time should be exactly the same up to some nanosecond from the master to the slave, and this independently of how long the path is on the network. So for that we do delay request, so we can have the slave, or sometimes it's the master, asking for a ping-pong message actually, and knowing those times, the slave can infer that half of the sum of those trajects is actually the time that the packets are taking to travel the network. So it can use, for instance, if it receives, it's 1 p.m. 1 minute, and then it receives that, well, but the packet is taking 1 minute to go through the network, well, it can correct that and say, okay, when I receive 1 p.m. 1 minute, it's actually 1 p.m., etc., etc. So for that, we can have a little Wireshark capture to see what's happening. So that's not the good way I used Wireshark. So I do a capture on my diagnostic interface. I let it run a reader, and I can filter. I can use the filtering on Wireshark to only show me PTP messages. So Wireshark can be downloaded for free, and all that is shown today is directly available from the free version of Wireshark. Nothing is added, there's no plugin, everything is built in. We see that we have two protocols of PTP. we have the PTP v2 and PTP v1. PTP v1 is actually the Dante clock, and the PTP v2 is the AES67 clock. So we can see here that the PTP master, the one sending the sync messages, is actually the 133 device, which is a merging device. And we can see that for a sync, for instance, it is sending a time here up to a nanosecond and even a correction. But the correction time is not added by the device, it's actually added by the switch, because the switch is on transparency mode. That means that in order to lower the jitter of a packet going through a switch, which is badly estimated when doing this kind of ping-pong that you saw before in trying to estimate the travel path of the packets on the network, the switch can correct the time but by compensating the actual time that the packet took to go through the switch. And this is this time. So we see that it takes 10 microseconds to the packet to go from the slave port on the switch, so on the master side, to the master port on the switch on the slave side. And this way we can achieve really great clock accuracy, and it's typically either you have a really well-designed network and you have a lot of money to spend, and then you can have every switch on your network that is a PTP switch, or you can have PTP switch at specific points on your network when you really need your PTP clock to be cleaned. Here we have the follow-up message. So this means that we are using PTP in two-step mode, because a sync message requires to be really precise in terms of time. It's not really the best way to send a single message, because you're not sure that at the exact time that it will be sent on the wire. So for that, the hardware can detect exactly when the packet is sent, then bring you back the data, and that is put in a different message, a follow-up message. So we can see that the follow-up message is not corrected, it's the sync message that is corrected. And if we look, the sync and the follow-up, they have roughly the same time, but not the same nanoseconds. So here we see 9 to 3000, and here we see 579, no, 50, so 1057. Yeah, so that's roughly 10 microseconds later, no more than that, 100, more or less 100 microseconds later. So this is the difference between the packet that was expected to be sent, so sent by the software or the hardware, and the exact time that it went on the wire. And that is because on the Ethernet wire you can only send one packet at a time. So even for a device, if it's at the same time sending audio and sending PTP packets, there can be a collision, which means that one packet will be delayed compared to the other. So of course you would expect the device to always send the PTP packet first, but if it is in the middle of a transmission of an audio packet, for instance, or any other packet, as a matter of fact, it will wait for this packet to be finished, then to send the audio. So the same is true for the switches. And then on the PTP v1 sync message, we can see that we have here the grandmaster clock UUID, and this means that the sync message is sent by a boundary clock, that is a clock that is the boundary, and here it is a boundary between V1 and V2, and the V1 boundary is slaved to V2, and here we have the master in the V2. So this is the device, the merging device that we saw before. So the switch that does PTP here is this RTL switch. There are many more other switches, and I'm not especially supporting RTL more than other switch manufacturers. It just happens that I have an RTL switch on my network, and it's really convenient to do experiments because you can configure a lot of things. So you can really easily mess up with your network, but if you know what you're doing, and if you know what you're doing, you can have really micromanaged, well-tailored configurations. So it's really a neat switch. And when we go to the PTP configuration, we can see if it's, yeah, okay, cool, that we have end-to-end transparent clock. So I can delete that, and it's a little bit slow, but it will come. Add a new PTP clock, which will be a PTP ordinary boundary, and I will configure it properly. So configure it to go through to be a boundary clock taking all the ports of the switch. Well, 1 to 8 at least, because I have no SFP on 9 and 10. Using not the Ethernet protocol, but the IPv4 multicast protocol. No one-way, priority 128, okay. And save. And so what will happen is that my Anubis, it was not the host, it was the Anubis which was a master. It's still a master, okay. But when I do the capture, and it is supposed to work, my PTP video sending the sync message. First, you see that it's a different rate of sync messages, because on this switch you can actually configure the sync message rate, so the rate at which the clock will take the actual time. You can configure it independently on the ports, so this is really neat to accommodate for the needs of some devices compared to others. But it's not 133 anymore, it's 143. And if we go to the announce message, PTPv2 announce message, we should see that we have no information on the grandmaster ID, but that's whatever. So here in the boundary clock mode, you see a new master. You see the switch that is acting as a boundary as a master for every device that is beneath the switch. And in your port configuration, here we should see that. So port 1 is the master, and here it's described as unclassified, but it should be slave actually. So it's the port where the switch is slave, so the port where the master is connected, and on the other ports it's either disabled or master. So our Dante controller clock, for instance, is slave as well. And all of that because when we look at our network, in the RTL, the Anubis, which is there, is connected on the blue switch, so PTP messages are coming from there, going to check to the root switch, to the RTL switch, and then all the devices on the RTL switch, so my PC, where I'm doing the captures on port 8, the Montone, and the AX box, so the Dante device, will be slaved to the switch instead of being slaved to the Anubis. So this has also the advantage that some, or on really big networks, you want to try to stress the master as little as possible. So I have this story that on one of these breakfasts that we did, we removed all the switches from being boundary clock, and we had 200 or 300 devices asking for trying to discuss to a PTP master, and the PTP master didn't like it at all. So the boundary clock has also this advantage of trying to separate some parts of the network. Okay, so yes, so two different modes of PTP on the switches: the boundary clock and the transparent clock. And we can see also that in the sync message we do have a correction there, but that's their own recipe of the switch. Maybe it's not correcting the origin timestamp, it's taking them from the master, and then everything is happening as a correction. But that behavior is different on each boundary clock. If I remove the PTP mode on the switch and I redo my capture, you can see that we are now back on 133 being the master, and there are no corrections anymore, because the switch is neither in transparent mode, neither in boundary clock mode, it's actually in just no PTP mode. Okay. So last is the RTP protocol. So the fact is that, as I told yesterday also, when you are inputting something in the network, you don't really know when it goes out, or even if the packet go out in the same order that as they are put into the network. So this is a feature of the UDP protocol, but this is not the feature that we are after doing real-time audio, because it can be really problematic to not know when you receive the audio and not know the exact sequence of how you receive audio on the network. So this is a really difference compared to ATM networks, for instance, or even just plain numeric digital connections, AES or MADI. And this is using the RTP protocol that was issued in the 90s, and that is using two things: the sequence number, that is the number of the packets, to be able to, so that the device can restore the proper order of the packets, and the timestamps. And the timestamp is actually the sample number of the audio when the audio was sent in the network, or actually when the audio was captured and put in the packet. And this timestamp is counted from the 1st January of 1970 and goes around. It's on 32 bits, and it's really that thing, the timestamp here, that is used by the receiving device to be able to place the packets into the buffer and to play the audio. And we can see that on Wireshark as well. So I can ask Wireshark to filter from RTP, and here we see a number of different streams. So here I have two different streams, for instance. I have two packets, and I can see that between the two packets of those two streams, the sequence is incremented by 1. And here the multicast, the time value is incremented by 24. So this means that basically I have 24 samples in this packet, and then the timestamp will be 24 more in the next packet. So all this information, you can find it as well, or most of this information, you can find it as well in the SDP that we saw yesterday. And you will use that mainly to do analysis on the network. But don't use Wireshark to do this kind of RTP analysis. You can do much more. So for instance, I can save that and like that. And I can go to a special website that is actually a service that you can download and run on your own computer, which is the list for the live IP streaming toolbox. And you can use list to do analysis on your packet captures. So here you have the first thing that is brought out when you start the app. So you just input your address, your email address, and then you can choose to upload a network capture file. So this one that we just made, and it will upload the capture. It will analyze it, and it will tell you what's happening on the network. So the number of streams that it found, and if all the streams are compliant with AES67, and what's happening if they are not. Why are they not? And this can help you in analyzing what's actually happening in your network if you are experiencing streaming problems. So it takes a bit of time because it's a huge capture, that not really that huge, but a lot of different streams. And you see that I use the profile that derives times for PTP packet, so I don't even have to synchronize my capture device. It's a little more precise when you synchronize the PTP time to your Ethernet adapter, to your network adapter, but it's much more complicated as well. And when using audio, you don't really need that much of a precision. So it's taking quite a bit of time. Let's go back later. And that's it. So we already started this kind of problem, how to analyze, debug, and operate such a network. So that's the problem. You want an AES67 network, but the technology is really young, and there are no really simple tools that exist to help you administrate the network. Well, there are some, but neither is either complete or perfect. So you have to know different things and different tools to help you try to pinpoint where the actual problem is on your network, or how to do the different connections on your network. So the first tool, and which is useful, especially if you're doing Dante and you don't have any SAP capabilities on okay. So I've got a bit of streaming problems. I'm sorry. No, it might be that so let me turn off the list software. So I hope it goes a bit better. And let's see. So RAV2SAP is especially useful when you don't have an AES67 that can do SAP announcements. I don't think there are many anymore, but if there are, you can use RAV2SAP, and RAV2SAP is also especially useful when you are trying to use copy-paste for Dante. So in RAV2SAP you can paste directly a SDP, and it can be announced using SAP, so that Dante controller is recognizing it. And of course, you can copy paste SDP in Dante using Dante Domain Manager, but you may not want Dante Manager on all the installation that you're doing. So another tool is Wireshark, and Wireshark is, as we see, a very fine tool, but also very complex to use and to master. So it's use it with care. And the thing I used to say is that maybe if you are using Wireshark and you debugged your network using Wireshark because you missed a tool in this toolbox that I'm describing here, maybe send me an email so that this tool is developed later. And when I say me, I say basically any engineer working on AES67, because it's your role as device manufacturers to provide the customers with the proper tools. So list, as we saw before, which can be downloaded at tech.ebu.ch/list. Very neat software and very efficient when trying to do stream analysis on your network. And then there's PTP track count. So PTP track count is the list of PTP actually. So it's scanning the network and seeing everything that is going on the network in terms of PTP. So PTP track count is developed by Mindberg, which is one of the leading PTP manufacturers, PTP Grandmaster. And so there's the PTP analysis on the network. Taking, for instance, okay, I have a Grandmaster, that is my imaging device, my Anubis. And then I have the boundary clock, and the boundary clock, which is between those two clocks, and which is V1 to V2, actually V2 to V1, as we saw before. And then we also have another boundary clock, but this is a Ravo device that is just not properly detected as just an endpoint device. And if a device is faulty or working not properly, it can be also indicated in this software. So you will have warnings when something is changing on the network. You can have the history of what's happening. So this is a neat tool to use on your network to actually do PTP analysis. Then we have Aneman. So Aneman, which is winning here. So Aneman is a way of doing the connections between the devices without taking care of the different source creation and destination creation. But the problem is that every manufacturer, the deal with Aneman is that every manufacturer has to actually do the configuration, provide a plugin that can talk the Aneman language into the software. So that's true for Ravo, direct out, and merging as well. And so we can do the connections. So I can connect those 8 inputs, AES1 inputs to the net 17 to 24 on the mountain. I just have to click on the matrix, to click to apply multicast, so that Animan can create the exact streams that need to be created, or reuse the streams that need to be created. And then we can see that the stream first was orange, indicating an error, but this is normal when first doing the connection, and then it goes purple, meaning that everything is working right. So this kind of tool is really useful as providing you a insight on the network and information on what's happening on your network, or are the different connections between the device, which connections are working or not. So you see that, for instance, there we are connections that are faulty. And also you have the list of devices, and it even recognize some of the switches. So you have you can directly access the web pages of the switch by double clicking. So it's kind of a discovery tool as well. So it's a neat software, but of course you have to be in these cases where you are using the exact equipments that are supported by Animan. And this is not always the case. So check with your manufacturers, or check with me, or on the Animan product page. We try to keep it updated, and I know that some manufacturers will be added in the upcoming weeks or months. So it's still a project. It's still an ongoing project. It's a lot of work, and we also have the enterprise version of Animan, which is more aimed at bigger networks and multi-user and multi-groups, etc., to avoid sharing the use of a network with a single Animan, and with security features as much as can be. Okay, and then there's M&Ms, which is M&Ms, which is a tool, another tool to visualize what's going on your network. And I may do a presentation dedicated to M&Ms later. So Tibor, you ask a question. So what does it mean when the connection in Animan goes orange then purple? So this is the case when an orange connection means it is in an error state. So maybe the device has its own way to communicating the error, and the error goes back to Animan. So for instance, there something is wrong here. We check here. Something is wrong as well. So I cannot find any connection that is orange, but obviously when it goes from orange to purple, and or from purple to orange and back to purple, it means that the stream was in a temporary fault state. So yes, this is a feature that I will add very soon, is that when there's an error, Animan keeps the knowledge of this error easily. So right now it is kept, but only in the log view, and it's not really the easiest way of having these error states. So maybe something that is more as right-clicking the output, etc. Yeah. So it's actually a perfect question that you ask me. So there goes the cheat sheet. What to look when something goes wrong, and this is exactly that Tibor that Heinemann is just telling you that something goes wrong, and obviously in a perfect world Heinemann would tell you exactly what to fix. The day it does that, I will retire because I will have nothing more to do. But that's my aim, and that's why I work on this every day. So at some point we will achieve that. You know, this magical one-button interface when you just have to the fix me button, and then you push fix me, and everything goes back to normal again. So first, some bedside reading to provide you from for knowledge on the different audio network protocols, and this is really fun to read, and also a different point of view on the relationship between AES67, ST2110, and Dante, because obviously I speak a lot about Dante, but just because they are the main actor on the business, and I'm not the perfect guy to talk about Dante because it's not necessarily the way I support the most of approaching audio over IP. So there is another way of presenting, and of course, and I have to say that it's not less or more valid than any other way. It's just another way of presenting how the network goes, and it's the user experience that matters in the end. Okay, so debug at setup. What happens when I try to plug a new device? And I promise that we will get back to your question, Tibor. What happens when I plug an equipment, a device on the network, and it doesn't work? So the basics are are the device connected, and do they have a compatible IP and net mask? So you would be frightened by how often this just is simple as that. And trust me, I have the experience on having such dumb problems. Then and having done myself. I mean, I'm not bashing on any customers. I did it myself. All the equipment synced to the same PTP clock. So if they have different PTP clocks, they will not be able basically to stream audio one to another. If they don't have PTP, are they subscribed to the PTP group, multicast group? So this is the address there, and that you can try to look for into the switch. Is the audio missing? So check the IGMP subscription and verify that a third party can receive the stream. And there's a really easy third party that doesn't require PTP to receive the stream, and that you can use to check really easily. It's VLC. So I will not do the VLC test because it messes with my virtual VPN. But you can download, and you saw maybe yesterday when we downloaded the SDP on the Horus, for instance. When we downloaded it, it appeared with the VLC icon. The streams, the SDP actually can be read as is by the by VLC, and if you have audio in the stream, if you can receive the stream with VLC, it will play the audio. So it's the best way to check that actually the problem is that either on the sender or on the receiver. No audio in Dante. Well, check if you entered correctly the multicast IP. You remember the multicast prefix we talked about yesterday. So this is also a very frequent problem that happens on the network. So also, if you have multiple network interfaces, there might be a problem about IP routing, and some IP, depending on the order that the interfaces were brought up, the multicast query can be sent through the wrong interface, especially with VLC. So check that. Again, it did happen to me a number of times, and it's always puzzling when this happens and you might not think exactly of what's happening. So always keep that in mind. Also, now everything is going fine. You did receive your audio, your own devices are connected, but then audio goes bad when streaming, when the network is on a stable state. So first, check the buffer. Jitter might increase, especially when the setup is getting bigger. So you are plugging your first devices, everything is going fine, and then at some point everything crashes. Well, check the buffer of the device. Try to put it at a very, very high value and check if this works. If this works at a high value, then there's probably a value in the middle that that might do the trick. So when receiving, you remember the buffer or delay can be set here on the merging devices, and on the other devices it's another parameter, but it's also always delay, jitter, etc., or jitter buffer. And here I set it to 42 milliseconds, so this can accommodate a lot of jitter, especially on a local area network. Check the bitrate on the switches as well. Your setup is getting bigger, maybe sometimes you exceed the maximum bitrate that you should use the liaison between one device and the switch or two switches. And if the problem, so I think if it flashes at slow rate, so if your program comes and goes, maybe it's an IGMP problem. So in the, what I didn't show you actually, but what we can look for now, in a multi-switch setup, there's a trick, and the trick is that you have to configure the timers properly. So back to the IPv4 configuration, interface settings, no IGMP snooping. Data, no, it's not there. VLAN settings, yeah. So in the VLAN settings, you have the timers, and the query interval timer, the max query response, and the max query interval. And those timers, they have to be the same on all the switches. And if they are not the same, then it can mess up with the way that the switch detects that a device is receiving or not the different streams, and it can abruptly cut the streams. So my especially for you, Tibor, which since you are reporting a problem that you can see with Aneman, the thing is that check the error message on the, when it happens, there should be an error message either on the sending or on the receiving side. For instance, here the RTP status. So this is the old version, this is the new version, and check the error that is brought up. And if it's not easy to understand, just drop us an email to explain that. This will mainly happen. So the number one problem is IGMP. Then there can be other things that happened, and you know, the network is a complex setup, is a complex system. So you can have various oscillations on the system. You can have instabilities. You can have all sort of funny things that just rebooting the switch or the sequence on which you plug the different devices on the network, they can play a role on how stable your network is. And it's always the problem that when a data center loses power, it takes weeks to start it again, because the very sequence, and not only saying the unsaved configuration on some switches, but the very sequence on which the different services are brought up can be really tricky. Okay, so that's all for today. As always, just don't hesitate to send me an email if you have any requests, any information, need for information on the different software that I presented there, or on AES67, on some merging device, or on anything. If you have ideas, if you have missing tools, if there's something you don't understand, even if you are still not convinced that AES67 is useful and that you prefer Mylan or Dante, just have a chat, and because I want to understand why, I want to understand your point of view, and this is useful. I mean, we are all trying to ease the life of our users, and different approach doesn't mean that we have to disagree on everything. So thank you, everybody, and have a great day or evening or whatever the time the rest of the day will be when you look at this stream. Thank you.